Quantum physics, once understood, can change the way you see things. Quantum physics has shown that in one moment, quantum particles can be in multiple places at once. It might be difficult to believe that we can also be in multiple places at once. And in this video, I'm going to introduce you to the multiverse theory, also known as the manyworlds theory. So stay tuned to the end, guys. To understand how we move in the multiverse, we first need to understand the infamous quantum physics experiment called the double-slit experiment. An English physicist named Thomas Young showed what happens when you shine a beam of light through a double slit and put a strip of light-sensitive film a short distance behind the double slit. What happens is the light goes through the double slit and imprints its pattern onto the film. What you see on the film when the light passes through the double slit is an alternating dark light band, which is called an interference pattern. And since this experiment, scientists have also tested this double slit method on physical matter, such as electrons, atoms, and other compounds. So when electrons are fired through the double slit, imagine them as tiny balls. And what you would expect when electrons are fired through is something that looks like this. There are two slits, so you would expect two vertical lines of imprints on the film. But to the surprise of all scientists, that is not what happened. To everyone's surprise, what actually happened is that we ended up with multiple imprints in a uniform pattern all over the film, like this. So the shooting of electrons as well through the double slit had also led to an interference pattern, just like the light. It was found that this experiment works not just with electrons, but with all subatomic particles. When they're fired, they behave like waves. Now, our physical body and the entire universe is made up of subatomic particles, so it's absolutely awesome how subatomic particles can behave like waves. Now, if you're a skeptic, you're probably thinking, well, what if you're just firing too many particles into the double slit and they're just bouncing off each other? Well, scientists have thought about this too. To account for this possibility, scientists changed the experiment and fired one particle at a time. They waited before each particle hit the screen before firing another. And guess what? Particles fired one at a time also created an interference pattern, which is a wave pattern. The single particle was going through both slits and interfering with each other to create a wave pattern. It was in two or more places at once, which is the only way it could have interfered with itself. And this double slit experiment is one of the most repeated experiments in quantum physics. The experiment concludes that a single electron somehow goes through both slits simultaneously. Now, electrons are represented by waves. The double slit experiment is evidence that this wave allows individual electrons to pass through both slits at the same time, and causing an interference and causing subatomic splits. According to the multiverse theory, or the manyworlds theory, there are also splits, many splits, that occur in our world. The theory implies that subatomic splits also occurs in bigger matters like ourselves, and as such, there are many states or versions of our reality floating around in many worlds. Now, the many worlds interpretation first began in 1926 when an Austrian physicist, Erwin Schrödinger, demonstrated that the subatomic world had possibilities. Now, many quantum physics experiments have shown that when you don't look at quantum particles, they stay in their many possible states, which is called the superposition state. However, when we look at the particles, their weight function collapses and they choose one of their many states. So we only see one of the many states, which is called the result. We don't know what the state is going to be until it's happened. So we only see things in one state. And if this is true, we need to remember that this applies to everything, because everything around us is quantum particles, including ourselves. So the superposition state is that there are many states, but when we are looking, we see one state, which is called the result. But what happens to all the other states that we don't see? So Schrödinger created a thought experiment. It was called the Schrodinger'scatexperiment. In this experiment, he imagined a cat in a box, and he imagined a bit of radioactive substance in the box as well. When the substance decays, it would cause a poison to release that would kill the cat. And there was a 50% chance that the poison, the substance, would kill the cat and it would die. So 50% chance that it would happen. For the time that the box is closed, we don't know whether the cat is alive or dead. We only know when we open the box. Now, if we look at this from a quantum physics perspective and apply the supposition principle, then we can say that when the box was closed and no one was looking at the cat, at that time, the cat was present in both possible states. This means that in one given time, the cat was both alive and dead. When we open the box and look, the weight function collapses and it chooses one of the possible states. And the end result is also one state. This is why if you keep repeating this experiment, you might get different results each time. You open the box, the weight function collapses and it chooses a state. Now normally, because our common sense takes over and takes precedent, we tend to use this method of accepting the result. But experiments and theories around many worlds have held up for about a century now. According to the manyworlds theory, all the possibilities that we didn't see are happening somewhere else. This means that if Schrodinger's cat is dead in this world, it was definitely alive in another world. When the box was closed, the cat was in a supposition state. She was alive and dead. When the box is open, there is a split where there are two copies, because there are two possibilities in this case. We can only see one state in one world, so the other state goes to another world. In this case, there are two states, but in different scenarios there may be multiple states. So the other states will go to other worlds. So if this theory is true, just imagine all our other possibilities are still out there in other worlds. When there are different possibilities, the particles make copies, and the other copies are in other worlds. And for that reason, quantum particles are everywhere. If you like this video, then please do not forget to hit the like button, subscribe and share, and I will see you on the next video.